Annex 11 introduces a brand new modelling paradigm called convergent modelling technology, where you combine working with facets, surfaces and solids without the need for any conversion. Working with scanned data is becoming very common in the medical industry, especially when designing implants for the individual. In this particular example, we will take a scan of the skull and see how we can directly use it to create a cranial implant. We start by importing an STL file of the skull. Next, we generate a sketch. That's basically the profile for the patch. By using convergent modelling technology, we are able to interact directly with the faceted geometry. Here we use the sketch we've created to subdivide the skull. We can then use the extrude command to actually generate the patch itself, noting that the body it creates is a facet body in Annex 11. Once we have our desired shape and depth, we can then use other typical Annex modelling tools, such as offset, to make a subtle change to the patch, remembering all the time that this is working directly on faceted geometry. Typically, these cranial implants or patches have holes in them to affect drainage and to encourage healing. So let's take a look how we can create these in our patch. First of all, let's create a sketch of one of the holes. And then what we may want to do is to pattern those holes within the boundary of the sketch. Finally, we extrude the sketch and the pattern geometry, make sure it protrudes through our patch, and then subtract directly from the faceted body. The other beauty about convergent technology is that there's a level of associativity. So again, if we make a change to our original patch profile, then the faceted body and all the actions that were performed on the faceted body would update. This is just one example where convergent modelling technology, new in Annex 11, can speed up the design process when working with faceted geometry.